Now we go to the third property of Z transform, which is time reversal. You can refer to slide number 23. Okay, let's say xn, when we perform the Z transform, you will get xz. So, time reversal property states that x negative n, by performing Z transform, you will get x z negative 1, which is inverse Z transform. Okay. What is the meaning of negative n? Actually, xn is refer to the right-sided signal. If you have un, the signal is at the right side. Okay. This is just for example. If you have x negative n, which is u negative n, the signal is flipped to the left side. You will get the signal like this. Okay, that's why we call it time reversal property. Now I just go to the example of time reversal property. Okay, for example, for time reversal property, okay, find Z transform of the signal to n u negative n. Okay, you must know that if you want to change this n to negative, you need to apply this equation. This is just fundamental equation that you need to perform. Alpha n will be changed like this. 1 over alpha to the power of negative n, because we want to change the whole signal from n to negative n. We want to follow the time reversal properties. So this one you need to remember. Okay, so from 2n u negative n, follow this the previous equation, you will get 1 over 2 to the power of negative n. If we rearrange this one, you will get, at the end you will get 2 to the power of n. Okay, it is just the same thing. Okay, next, let xn signal equal to 1 over 2 n. This is not time reversal signal because we already changed negative n to n. Okay, if we perform this Z transform of the signal, from table of Z transform pairs, you will get this answer, Z over Z minus 1 over 2. So what happens if you want to change from xn to x minus n? So you will get x z minus 1. Okay, now we just need to change z to z minus 1 because the equation wants you to change from xz to xz minus 1. As simple as that. And then we just rearrange z minus 1 to 1 over z over 1 over z minus 1 over 2. And then cross multiply this one, you will get like this, and can remove the z. At the end, you will get 2 over 2 minus z. So how about the regions of convergence? 2 minus z equal to 0. So z less than 2. Okay, this is the only regions of convergence left. Now, the fourth property is multiplication by an exponential sequence. You can refer slide number 24. This multiplication is also known as scaling property. Okay, let's say we have xn, then we use z transform to get xz. Then, to apply scaling property, you will get the equation is like this: a to the power of n xn. By performing z transform, you will get x z over a. Okay, how to prove this? We'll get this one. Okay, first, as usual, you need to use general equation. This is the general equation. So you need to perform z transform for a n x n. Okay, you will get like this. Okay, a n x n z to the power of negative n. Okay, you just need to substitute for xn. You just substitute xn, but in our case is a to the power of n xn. You need to perform z transform of this signal. So you just replace it into this equation. And then rearrange it. Okay, xn, you will get z over a to the power of negative n. Okay, in previous property I already explained to you, a to the power of n, we can change it to 1 over a to the power of negative n. Okay, so that's why a is below and z is above to the power of negative n. So at the end you will get like this: x z over a. Okay, based on the previous equation, xz, xn, z, negative n. When we want to change z to z over a, this z will follow to z over a, like this, z over a. That's why x z over a, you will get the equation, z transform equation is like this. Okay, now we will perform example of multiplication by exponential sequence property. Okay, actually the question is wants you to find z transform for this signal, unit step signal, a to the power of n u n. So directly we apply x z over a equation, z transform equation. So we know that if un is equal to xn signal, perform z transform for un, you will get z over z minus 1. So when you apply the multiplication by exponential sequence a to the power of n, automatically the xz here will change to xz over a. So z transform for this one, z over z minus 1 is equal to change z to z over a. So it is equal to z over a over z over a minus 1. Okay. Change z to z over a. And then rearrange the equation, you will get z over z minus a. So how about the ROC? Z minus a bigger than 0. So z bigger than a. Okay, this is the regions of convergence for this one. Okay, the last property that I will explain to you is convolution property. You can refer to slide number 24. Okay, let's say we have x1n, okay? By using z transform, you will get x1z. Okay, and x2n, by applying z transform, you will get x2z. Multiplication property states that, okay, if we multiply two signals here, you will get the convolution of these two equations of z transform. But convolution property states that the convolution of these two signals will get the multiplication of these two z transform. So now we need to apply the convolution property. This is the equation. Now we go to example of convolution property. The question asks you to find z transform for the following signals. Okay, we have u n minus 1 convolution with delta n, which is impulse n. Okay, this is time shifting property. Okay, you need to apply time shifting property. You will get z minus 1 because n naught is 1. So n naught here is z minus 1 multiplied by z over z minus 1. So please refer to time shifting property. Okay, explanation for this time shifting property. Please refer to this one. And then multiply this both equation, you will get like this, 1 over z minus 1. Impulse is, z transform for impulse is always 1. And then you will get 1 over z minus 1. For B, example for B, I hope you can find the ROC for 1 over z minus 1 by yourself, okay? For question B, u n minus 1 convolution with impulse n minus 1. Both of these terms, this function is time shifting property. Okay, so you just need to apply this one, u n minus 1. Just take it from here, 1 over z minus 1 here, multiply by impulse n minus 1. Actually, this one, impulse, you can get it from the table of z transform pairs. And then multiply both of these z transform, you will get z minus 1 over z to the power of negative 1 over z minus 1. Rearrange it, and then you will get 1 over z multiplied by z minus 1. Okay, how about the ROC? Okay, ROC, z bigger than 0, z minus 1 bigger than 0, z bigger than 1. And then draw the z plane. You will get z bigger than or equal to 1. Now example for part C. Okay, given xn signal 1 over 2 to the power of n un, convolution with 2n u negative n negative 1. Okay, so assume that this function is x1n and this function is x2n. So we perform the z transform for x1n. x1n is 1 over 2n un. So perform z transform, you will get this equation. This equation you will get it in the z transform pairs table. And then for the second signal is x2n 2 to the power of n u negative n negative 1. Okay, from the z transform pairs table, you will get negative z over z minus 2. And then rearrange the equation, you will get like this, z over 2 minus z. And then from convolution properties, you need to multiply both of the z transform. Okay, x1z multiply by x2z. So x1z is here and x2z is this one. Okay, so multiply both of this equation, you will get this new equation. Okay, and how to find the ROC? Z minus 1 over 2 bigger than 0, but so you will get z bigger than 1 over 2. But for this part is 2 minus z. 2 minus z is come from this signal. Okay, this signal. So the reversal signal, time reversal signal, negative n, the left-sided signal. So that's why it is less than 0. 2 minus z less than 0, z less than 2. So the ROC is between z between 1 over 2 and 2. How to draw it? It is simple. Just draw two circles. The first circle is 1 over 2 and the second circle is 2. So the ROC is inside between these two circles. This is the ROC.